What's going on, everybody? We're moving on to Chapter 9, 9.3, Properties of Tangents and Chords. So remember, we've talked about tangents and chords. They were part of our vocabulary from 9.1. So we're going to dive in a little bit deeper. We found out what they were, but now we're going to find out the properties of them in regards to circles. Okay? All right, a quick do now. Find the measures of arcs MP, PMN, and NPN. All right, so if we go through MP, right, we see that is this arc right here. We know that NP right here is a diameter, which means that this is cut in half. This over here is 180. This over here is 180, right? And if this little piece is 80, that means this little piece over here has to be 100. So that's arc MP. If we do is a different color, PMN, that means we go to P, then to M, then to N, right? We go this way. And once again, we've already said this, PN or NP, that is a diameter, which means it gets cut in half. So that means that one is going to be 180 degrees, right? And then I guess I could write that over there. That was 80 degrees, or sorry, that was MP was 100, PMN was 180, and NPM. Notice, right? It's really important to realize that the second and the third options are using the exact same letters, but they're in different orders, which technically makes them different arcs. All right, so if I use green, PMN, NPM. PMN was a semicircle. Now NPM has go N to P, then to M, right? So that's very clearly more than 180. We know that that's 180, and we said that this one over here was 100. So 180 plus 100, that means that one's going to be 280 degrees. Okay, so that's just review of what we did in lesson 9.1 and a little bit of 9.2. Okay, oh, sorry, I forgot to mention, I usually do, but the notes for this lesson and the PowerPoint slides are in Canvas. Please make sure you're going into Canvas so that way you're using the notes, or if you're not using the notes that I provide, please make sure you're doing your own notes, doing something to make sure that you know all this information. All right, so real quick, review tangent, a line that touches a circle at only one point, right? So we see that the point of tangent C here as T, line L touches our circle C at just one place, one point. Okay, so properties of tangent. If a line is tangent to a circle, that means it is automatically perpendicular to the radius. Okay, remember, perpendicular means meet at right angles. Excuse me, perpendicular means 90 degrees, right angles, right? So if we draw a radius and a tangent, that automatically means that angle is 90 degrees there. Okay, which means we can then form a right triangle and solve for any missing sides. When solving sides of a right triangle, make sure we remember, shout out to chapter 5, Pythagorean's theorem, a squared plus b squared equals c squared. Sorry, not chapter 5. That was in chapter 8. Chapter 8, Pythagorean's theorem, a squared plus b squared equals c squared, right? If that's a tangent line, that means we are automatically creating a right angle there. And now you have a right triangle, and you can find different side lengths and whatnot from that. Okay, so some examples, find the lengths of the radius x, right? Remember, a squared plus b squared equals c squared, or leg squared plus leg squared, that's a bad squared, but it's a squared. Leg squared plus leg squared equals hypotenuse squared, which means that that's our leg, and that's our hypotenuse, right? And then we just use Pythagorean's theorem to find x squared plus 12 squared equals 13 squared, right? Can't do anything with x yet, leave it alone. 12 squared is 144. And 13 squared is 169. Subtract 144 from both sides. All right, those cancel out, and we end up with x squared is equal to 25. Take the square root of both sides. Square root of 25, x is equal to 5. All right, so that means this length here, or a radius of our circle, which is a vital piece of information if we want to find circumference or anything like that, is 5. If we do the other example here, right, that's a leg, that's the hypotenuse, right? Remember, the leg, or x, is most likely going to be your radius, so it's probably going to be a leg, right? And then we end up with x squared plus 15 squared equals 17 squared. All right, and we just calculated that out. X squared, we can't do anything with it yet. 15 squared, or 15 times 15 is 225. 17 squared is 289, right? I'm kind of running out of space, but we would subtract 225 from both sides. We would end up with x squared is equal to 64. 289 minus 225 is 64. Take the square root of both sides. Those cancel, and we get x is equal to the square root of 84, which is 8. The square root of 64 is 8. So that means our not our hypotenuse, x, or the radius of the circle, would be 8. Okay? Okay, congruent circles and arcs. Two circles are congruent if they have the same radius. Two arcs are congruent if they have the same measure and are of the same circle or of congruent circles. Okay, so we've talked about arcs. We talked about that in 9.1 and 9.2, right? Tell whether the red arcs are congruent, explain why or why not. Okay, we see that we have the red arcs there, so let's use red. Nice, we already are. The angle is 80, that angle is 80. These are part of the same circle and they have the same degrees, so that would be a yes, right? This one, they are of the same degrees. They're both 90 degrees, but notice, right? The lengths of these arcs, while they have the same measure of degrees, they are not going to be the same length, right? Because we see that from circle here, the value of this radius is not the same value as, if I use a different color, as the other radius. Okay, so even though they have the same degrees, they are not going to have the same length because they're not of the same circle. They don't have the same radius, right? So that would be a no. Okay, over here we see that the angles are the same, 95 and 95, and we see that the radius of both circles are the same, so that would be a yes. Okay, perpendicular bisector. If a chord is a perpendicular bisector of another chord, then one chord must be the diameter. If we take a look at this picture, right, very clearly it would show that SQ would be the diameter. TR is very clearly off to the side, right? But if it's a perpendicular bisector, that automatically means that SQ would be the diameter. Remember, review, bisector means cut a line into two equal halves. So we see that SQ cuts TR into two perfect halves. We can tell that due to the congruence marks, right? RP is congruent to PT, right? Those are the same distance. So that means SQ has to be a diameter. Okay, so some examples, find the value, the length of X, right? There isn't an X here, but let's say if X was right here, right? We can see that this is a diameter because it's going through the center, right? And we see that it is perpendicular. If it is a diameter and it's perpendicular to a chord, that means it automatically bisects. So if this length here is 7, that means this X also equals 7. Okay, same thing. We can tell that BD is totally a diameter, which means that it has to cut AC in half, which means that this half has to be congruent to that half. And now we have an equation. We just set it up. 4x is equal to 3x plus 7, right? Combine like terms, subtract 3x from both sides. 4x minus 3x gives you x is equal to 7 there. All right, if we use a different color, once again, you can see that this is a diameter and it is perpendicular, right? That means it has to cut these two in half. Same thing, that side has to be congruent to that side, so we set these equal to each other. 5x minus 6 is equal to 2x plus 9. All right, once again, combine like terms, subtract 2x from both sides. 5x minus 2x gives you 3x minus 6 equals 9, right? Add 6 to both sides, we get 3x is equal to 15. And then divide both sides by 3, and we get x is equal to 5, okay? And then if you want to, you can double check and prove that it's true, right? If x is equal to 5, and we plug 5 into x here, 5 times 5 is 25, minus 6 would give you 19, right? 2x, if 2 times x and x is 5, 2 times 5 is 10, plus 9 is 19. That's how you know that they are the same. They are congruent to each other. Okay, properties of chords. Nice, look at that typo. Properties. Two minor arcs are congruent if the two chords are congruent, right? Arcs are congruent if the chords are congruent. So if we take a look, arc AB, if we use blue, arc AB is going to be congruent to arc CD if and only if we can see that arc AB is congruent to chord line segment AB is congruent to segment CD, right? So that means if the chords are congruent, the arcs are congruent, and the same is true for the flip-flop. If the arcs are congruent, the chords will be congruent as well. Okay, some examples, right? If the measure of arc AB is 110, find the measure of arc BC, right? Well, we can totally see that these two chords are the same length because they're both 9, right? So if this one is going to be 110, that means we automatically know that that one's 110. That one's pretty simple, right? Now, if we change it, if arc AC is 150, right? If we erase here, and in a different example, if arc AC, which is this arc here, is 150, find the length or find the measure of arc AB, right? So that means we have to find these ones. We already know that these arcs are congruent because the chords are congruent, right? So if that one, if we don't know what it is, let's label it as X, right? And if we know that they're congruent, that means both of those have to be X. And remember, if you are working with the entire circle, an entire circle always measures and adds up to 360. So you would just have 150 plus X is equal to 360, right? So combined like terms, we would end up with 150 plus 2x equals 360. If we subtract 150 from both sides, we would get 2x is equal to 210, right? 210 would be that. And then we divide both sides by 2. X is equal to 210 divided by 2 comes out to 105 degrees. So that means this angle has to, or sorry, not angle, this arc has to be 105 degrees. And that means this arc over here has to be 105 degrees. Okay, so that's how you would do that, right? Find the measure of arc GF, right? We totally see that these are the same, right? The radius is the same, the arcs are the same, the chords are the same. So therefore we know that that one's just 80 degrees, right? That one's pretty simple. Right? In the same circle or congruent circles, two chords are congruent if they are equidistant from the center. Remember, equidistant, if you break it down, sounds like equal. Distant, it just means distance. So equidistance means same distance. Okay, so if we take a look at this picture, right? Segment AB is congruent to segment CD if and only if, right? So if we take a look, AB must be congruent to CD if and only if FE is congruent to EG, right? That's how you can tell. Usually you'll have to have something given to you to be able to know that, right? All right, so if we do some examples again, find the value of X, right? We see that these chords are the same, 16 and 16, so that means they have to be equidistant, which means these lengths have to be the same. If these lengths are the same, we set that equal to each other, right, for our equation. That line has to be congruent to that line because those two lines are congruent to each other. So we set that up. 5x minus 9 is equal to 2x, right? If we subtract both 2x from both sides, I always like using the smaller number to get rid of, but it might be easier to do the 5x. So if we subtract 5x instead, 2x minus 5x gives you negative 3x, right? And then if we divide by negative 3, negative 9 divided by 3 gives us positive 3. So that means x has to be positive 3. All right, if we do the other one over here, right, once again, we see that the chords are the same length. They're both 15. That means they have to be equidistant, which means these distances have to be the same. Once again, we set that up. X plus 8 is equal to 4x plus 1. All right, subtract x from both sides. You get 8 is equal to 4x minus x gives you 3x plus 1. All right, subtract the 1. You end up with 3x is equal to 7. Right, divide by 3. Right, you don't get a perfect answer there, but that's okay. Don't be afraid of fractions. Don't be afraid of decimals. 7 divided by 3, x is equal to 7/3. Or if you wanted to get a decimal, if I type that into a calculator, 7 divided by 3, that would give you 2.3 repeating, okay? There we go. All right, and that's all that I have for you today, all right? So make sure, like I said, you're taking notes, bring lots of questions to class. Have a great day. Go Mustangs.